Good morning, everyone. So the session starts 15 minutes late because of the issues with security today, but the program will be postponed 15 minutes throughout the morning. It is the last day of the Congress today, and there will be still 3 outstanding keynote speakers coming, and then the last sessions afterwards. We need to vacate the venue at 12:15, so please do not hang around. We need to go out because the place will be reorganized for the next event. Don't forget to sign the manifesto, not only on the board, although there is not much space left, but please do sign electronically. You can distribute the link to the form as you wish. It's open. Don't hesitate, disseminate. This morning we will welcome Madame Agnès Pannier-Runacher, the French Minister for Ecological Transition, Biodiversity, Forests, the Sea and the Ocean, and Fisheries, sorry. Normally at 9:15, so around that time, after the first keynote speaker, if all goes well. Now I hand the floor to the moderators of the keynote session, Diva Amon and Daoji Lee.
Thank you, Jean-Pierre. Good morning, everybody. My name is Diva Amon. I'm a marine scientist with the Benioff Ocean Science Lab at the University of California, Santa Barbara, and a small NGO in Trinidad and Tobago. I'm also a member of the International Scientific Committee with my colleague, Daoji Lee, and this morning we'll be your co-chairs. So our first speaker this morning will be Ambassador Alejandra Villalobos, who is the Executive Director of Amigos Isla de Coco, or FICO, a non-profit NGO established in Costa Rica that mobilizes and implements human, technical, and financial resources to support the effective management of the Cocos Marine Conservation Area and the surrounding critical ecosystems of the Eastern Tropical Pacific. Alejandra?
Morning. The ocean is an ecosystem that connects us. It's that covers the 3 waters of the planet. Our planet Earth is a source of life, a common and the best legacy for future generations. Let's imagine we could have there in our hands. What would you do? Probably many would look thousands of ways to keep it, or spinning to satisfy this of the planet. Do you know what I do to keep it the balance? I will call a scientist for 3 reasons. Number 1, they have the most valuable information. Number 2, they always consider the past, present, and future. Number 3, they have passion and commitment to explain what seems impossible to explain. Keeping the balance of the biggest natural resource of the planet, the ocean, is a terrifying challenge. But thanks to its size, it's a big natural laboratory for investigation. And it shows many extraordinary things. Also, it alerts us about the big threats of the human create. The research, science, and work for many people present here today is the pillar of the decision for to protect our blue resource. Management and protecting the ocean require many leaders. Also, we need to strengthen governance models and inclusive partnership initiative. Remember, the ocean is the model to follow. We should replicate this connectivity without borders. Some species, like a shark, determine some ways they complete their life cycles, and we could do the same. It's necessary to conduct science, its finding and recommendation, with robust and realistic public policies, and we need to create innovation solutions. At the same time, we should promote constant cooperation, financial, technical, and beyond, so we can reach the goals and to continue researching the big ecosystems. For the more than 20 years, I have helped to protect a unique ecosystem, Cocos Island. I am very aware that this island is a green and exceptional treasure of the 40 square kilometers, where we can find endemic and vital species for the planet. The national park has 4,000 square kilometers of extension, with a bigger than Costa Rica land, representing a natural laboratory for research, and is also a key site of the East Marine Corridor. Let's not forget that science changes and transforms, but its ultimate objective is to keep the planet spinning in the balance. Remember, we are the crew members in the planet and not just passengers. Thank you.
Thank you so much, Alejandra. It's such a pleasure to have you with us. So we're going to move on to our first keynote of the morning. This is going to be by Alexander Thuja. He's a professor at the Oceanographic Institute of the University of Sao Paulo and a coordinator of the UNESCO Chair on Ocean Sustainability. Alexander Thuja's presentation will be entitled Marine Litter, Unveiling the Encrypted Message in a Bottle.
Good morning. Today is a special day because yesterday we had an inspiring moment in the opera. So thank you, Jean-Pierre. Thank you, everybody that created that opportunity, that moment. And now we need to move on and keep going with the changes we need to do. And one of them deals with marine litter. And we have some messages, some encrypted messages in a bottle. The idea of this presentation is to bring to you some challenges that we have facing this extremely important problem that's everywhere, like this. This is a picture from Belém in Pará, Brazil, where the COP30 will be hosted. And you can see the fishermen boats floating in garbage. This is not only the reality of Brazil, of some parts of Brazil, but it's the reality of several parts of the world, because the problem is all around. It's inside us, it's in the deep sea, it's floating, it's on the beaches, it's in the air. We have macroplastics, we have microplastics, we have nanoplastics all around. And this is a problem for the economy, a problem for the biodiversity, and a problem for ourselves. And there are some projections for the future that show us that if we keep the business as usual procedures, the problem will only increase. But we have possibilities, different possibilities of futures that we can build. And that's why we are here, to change these possibilities of futures. In a way, we can have a healthy ocean, a clean ocean, and a productive ocean. To do that, we need to close some taps. And there are several types of taps, and we need to understand that. Because we have the sea-based sources, we have the land-based sources, but they are all different. When you look at these types of litter, every type of litter tells its own story. It's a different story. When you look at the cigarette butts or fishing lines or fishing nets, or even products that we use to clean ourselves at home and that are appearing at the beaches, we see that there are different sources, sinks, processes, compartments, and effects. So we can define marine litter, as we defined it in the example report in 2019, as a wicked problem that has no easy solution, and that demands science, that demands wish to change the situation. And we are in a very important moment with the treaty that's being discussed and that will finish in 2 months, hopefully, where we expect to have ambitious decisions to change this reality. So the idea is that we have an encrypted message, and that marine litter is a problem, of course, but it's also a symptom of an unsustainable society, an indicator of the entropy of the socio-ecological system. And when we understand that, we need to look at the sources, the causes, the underlying problems that generate this important issue for biodiversity and for us. Since the 60s we have, and 70s, we have some policies like the MARPOL Convention, the London Protocol, but more recently we have movements in UNEP, United Nations Environmental Program, that started to consolidate our strategies to face the problem. So we have the Global Program of Action for the Protection of the Marine Environment from Land-Based Activities, the GPA. We have the GPML, which is the Global Partnership on Marine Litter, but now changed to plastic pollution and marine litter. And in 2011, the Honolulu Strategy, which was the first comprehensive strategy to face marine litter that's been unfolded in the treaty this year. The importance of SDG 14 and the links of SDG 14 with other SDGs mediated by the litter, the trash, the garbage, is another important issue. And we have one specific target dedicated to marine litter, which is a 14.1. So by 2025, this year, prevent and significantly reduce marine pollution of all kinds, particularly from land-based activities, including marine debris and nutrient pollution. I think that you will agree that we are not doing that by 2025. We need to move on. We have the ocean decade with some expected outcomes directly related to marine litter. You can see a clean ocean, a healthy and resilient ocean, and a productive ocean, because with litter, the ocean is not productive. Okay? And then we have the plastic treaty. So we have policies, we have tools, we have ways to move forward, but things are not changing. And that's the point. We need to advance in some aspects, and my message here, the encrypted message in a bottle, will focus on these type of things. So I would like to face science, indicators, and governance issues as challenges to be overcome in the next years so that we can advance in our capacity to fight marine pollution, and especially marine litter. So when talking about science, I would mention hotspotting and the safe levels of microplastics, so kind of risk assessment. In relation to indicators, the data acquisition, sharing, and products related to the data, including a controversial potential of citizen science to solve all the problems we have in terms of data, and the governance issues, including the science policy interface. So we are making several exercises to promote, to conduct hotspotting estimates. This one is a relatively recent one in 2017. And we showed that the Amazon River and the La Plata River in South America are the biggest entry points of litter into the sea, into the South Atlantic and Equatorial Atlantic. And then but we need to have a little bit more data to do these models, and we need to validate them. This is an important scientific challenge that we need to overcome. We tried to do that in Brazil for the 5,570 municipalities, considering all the data we had available. Based on more than 50 databases, we found that only 29% were appropriate to be used. What does it mean? Appropriate means data that are recent, at the municipal level, and not self-declared. So it's a very basic type of information that we need to have inputs on territory, on the wind, on the rain, on the slope, on the hydrology, population density, and socioeconomic condition, and also solid waste generation and management. So we need this type of information. Because when we talk about marine litter or garbage or waste, we think it's easy to get information. No, wrong. It's not easy. We need to have ecosystems of institutions generating the data so that they can be organized and used. This is the result of this type of exercise that need to be improved, considering appropriate proxies, the decay rates of litter along rivers. This includes litter behavior in watersheds, and also the role of dams that block the litter passage. We came up with some huge estimates of litter generation in Brazil for the environment. It's about 16 kilograms per person per year, so it's a lot. And then when we look at Belém, remember the first picture? This is the information behind that picture. Why Belém and other municipalities in Brazil are facing so bad situations? Because we have in that situation big population, low per capita income, subnormal settlements, the red boxes, social inequality. We have a lot of plastic consumption, low recycling capacity. We have a coastal municipality, so it's very close to the sea, and a big pluviosity, one of the biggest pluviosities in the world. And we have a low capacity of governance related to litter, and then in the end we have a big risk of leakage to the ocean. That's the footprint or the fingerprint of the generation of marine litter in Belém. So we need to understand that and use that information to face the drivers and find responses to them. But it's not only the only problem. We have risks. We need to assess risks. And then GESAMP prepared a report, and it has a working group focusing on that, trying to understand how can we do that if we have different types, sizes of microplastics with different types of effects on organisms in different organisms. So it's important that we understand this so that we can calculate the safe limits of consumption of microplastics, because we are all consuming microplastics. We are breeding microplastics. We are eating microplastics that sink in our food, not only in shellfish, sorry. And then that's why we need indicators. Indicators are extremely important. Indicators relates to science and relates to data that's not necessarily science, but can support science. So we need to produce indicators on an everyday basis to face and to solve what we are calling policy concerns. We need to know where's the litter, what are the hotspots, what's the trends, how can we solve it, what are the processes. And these are policy relevant questions that we need to understand, considering the data we need to produce, we need to organize, we need to share. So GESAMP did a very important step in 2019 with this report, trying to organize the way we generate the data with harmonization, with standardization. And to do that, we need institutions, we need processes, we need capacity building, we need mentoring. That's why IMDOS, the Integrated Marine Debris Observance System, is so important, together with other monitoring efforts like the IPBS framework is trying to put in place. And without this type of process of arrangement, institutional and governance arrangement, we are not being able to have local data, subnational data, upscaled to the global data, to the global scale, so that the UNEP's digital platform could capture this and use and create products that are useful for SDG 14, for the decade, for the countries, for everybody. So the digital platform at UNEP is a powerful tool that needs to be fed, but we do not have all the data to feed it. That's our challenge. And citizen science is not a panacea. Citizen science is an opportunity. It has benefits to science, to citizens, to the environment, but also have challenges. And one of the challenges is that citizen science should be understood as an avenue of two ways. Information coming from citizens to science, but also return from science to citizens, so that citizen science becomes an incredible and powerful tool for social control. To create citizens, in fact, that will fight for the basic aspects that generate marine litter. In the end, we can see that indicators should be produced everywhere, forever. And that's why, as a provocation, I think we need to make the South become north in terms of capacity, political capacity, institutional capacity, financial capacity, and long-term monitoring. Of course, we have exceptions in the north and in the south, but the idea is to improve the capacities so that we can have governance processes that are healthy, that are participatory, that consider integration of different policies that are integrated, that are related to marine litter, like tourism, like environmental issues, like solid waste, like coastal management and sustainability, including science and technology. And then we also need to integrate different stakeholders in the discussion, understanding, producing, generating products based on the data. This type of indicators of generation, exposure, and effects of marine litter. This is our challenge so that we can move on. In Brazil, we have an exercise that we are calling IPOS-like. IPOS is the International Platform for Ocean Sustainability, where we create processes and governance arrangements to internalize the agenda of marine litter within coastal states. We have now 8 coastal states integrated in collaboration with the Ministry of Environment and other institutions to produce state strategies so that we can move on. We can understand the problem, we can face the problem, and we can see the changes. So the idea of the coastal, of the Clean Ocean Network is to contribute to SDG 14, the Ocean Decade, and also the implementation of the treaty. We also aim to facilitate this science-based participatory governance process to combat marine litter. So you can see lots of people of different sectors over there, and consolidate an integrated and structured strategy to monitor the problem like IMDOS. So this could be understood as a national branch of IMDOS that should be, in my opinion, personal opinion, should be fostered, should be supported by UNOC, by the treaty, and so on. Going to the end, we need to upscale, and to upscale, we need local data, global data, we need infrastructure, we need institutions that are well supported to do its mandate, or their mandates, and this means GPML, which is a very important arrangement that is trying to put the community together so that we will together find ways to face and solve this problem. In the end, that encrypted message says that marine litter is more than a bottle, whose message calls for better articulation between science and policy under a co-design and sustained process. So we need to understand the causes, and the causes sometimes are linked to poverty, not necessarily waste management. Waste management is important, but we need to understand why there are so many people without the capacity to deliver the waste and have a final disposal, appropriate final disposal. What's out there? It's not only management. It's several other things that we need to understand and advance. So thank you very much. Hope the message touches your hearts and your minds so that we can move on with the next steps after this meeting. Thank you very much.
Thank you so much, Alex. It's so impressive to see the scale of work you've done in Brazil. Thank you for your leadership. So we're going to have 5 minutes for questions now. If you have questions for Alex, please just put your hand up. You have your mics in front of you. Please. Don't be shy. Yeah.
The bottled water problem is so massive. I was in Thailand or even in Barcelona, and these countries depend on so much bottled water because their infrastructure and their piping is so out of date. But I see out here just by the staircase, so as we enter, there's a water filtration system, and I think it'd be amazing if we could have those, all over every city, especially in the tourist zones. In Thailand, I walked every 6 feet in Koh Chang, and it was nothing but huge chunks of plastic. And I started picking it up, and the locals were like, "Yeah, good luck. You'll be doing that all day and every day." So it's so overwhelming.
Yeah, I agree. And normally, when we have a problem, we also see opportunities. And when we have this type of removal of litter from facilities to clean the water or to clean the sewage, we may have indicators. This is one of the movements that we are trying to have in Brazil, so that these companies collaborate in sharing the information, because they produce this data on a daily basis. And this data is not entering our ecosystem of information to understand the problem. So this could be an opportunity that we can use. So talk to your companies, clean water, the companies that clean water, so that we can perhaps have this type of information, and we will have this around the world. So the opportunity is out there.
Thank you, Alex. Other questions? Right here. And then.
Hello, thank you very much. I was wondering if you could tell us how far we are from having a global number of the number of litter or plastic in the ocean, at the global scale.
Yeah, we have good estimates that are based on models or that are based on observations. And the models depend on the understanding of the functioning of the ocean. This includes the behavior of litter when it's in the water, when it's in the sea, because most of the litter sinks. Not because of the density of the plastic, but because of falling of the organisms that settle on the litter. So we need to improve our understanding of the functioning of the sea and in the integration with the behavior of the litter, so that we can understand where are the litter and how much is out there. And the coupling of models from the local scale, like bays and coastal areas, to the big scale, to the ocean basins, is a challenge too. So we still need to have ways to integrate what's being leaked from the countries to what's out there floating or at the bottom. So the challenge is out there yet.
Where was the question you saw? Do you remember which one?
Anna.
I thank you, Ana Colas from the University of the Azores, Portugal. It's really interesting, your talk, and I wonder, as you said, all the litter, it does not stay in the surface, it sinks, and it sinks to the bottom of the ocean. And you have a lot, especially in Brazil, you have the margins, and then you have all of these canyons. Do you manage to assess the amount of litter that is accumulated on the deep sea? Did you try to do that? This is something that you have plans to do? And when you talk about enterprises that are cleaning, are they just doing on the surface, or they are also going to the deep sea in order to do that? Thank you.
Thank you, Anna. Yes, there are some fragmented initiatives in Brazil to understand what's the litter is in the deep sea, considering trawling and considering ROVs, images. So we are in the very beginning. But in a not so deep area, there is a very nice experience in the state of São Paulo that we call payment for ecological services. For the fishermen, that when trawl for shrimps, they also trawl litter, and they bring back the litter and receive some kind of refund of money from the state government. And this can be done in deeper areas too, although trawling is a complicated fishing strategy that causes problems to the biodiversity. So this is an important aspect that we need to consider. But most of all, we need to prevent litter to go to the sea, because when it's there, you can imagine how expensive it could be to remove litter from the deep sea. So it's a problem. I think there is another one, but I don't.
A last round of applause. We need to move on. Yeah. Okay, I take over very quickly from the moderators of this session. Ladies and gentlemen, François and I are very honored to welcome Madame Agnès Pannier-Runacher, who is the French Minister for Ecological Transition, Biodiversity, Forests, the Sea, and Fisheries. Minister Pannier-Runacher has, I want to mention two facts about the minister. First, she launched the Year of the Sea in 2025. It's a nationwide program which highlights over 130 events to raise awareness about maritime issues in the country. She has also championed a program which was discussed at this very meeting, a program to decarbonize the maritime transport through initiatives such as the Ifremer low-carbon ship program, which supports innovation and accelerates the production of low-carbon ships and boats. Minister Pannier-Runacher's dedication to ocean health and ocean actions underscores her commitment to aligning environmental preservations with economic development. Please join me in welcoming Minister Agnès Pannier-Runacher.
Ladies and gentlemen, dear scientists, France is really honored to welcome you today on the occasion of the United Nations Ocean Conference and the inaugural edition of the One Ocean Science Congress. I am both pleased and proud to host so many of you. Over 2,000 scientists from more than 120 countries. This is truly unprecedented. Thanks to your presence, the city of Nice becomes for a few days the global capital of oceanic research and scientific inquiry. This Congress is essential in at least two major respects. Firstly, because in ecological matters, we need science urgently and more than ever. To better protect, we must first better understand. Understand the mechanisms of climate systems, understand the complex interactions between ecosystems and human activities, understand the repercussions of pollution of water, air, and soil on both biodiversity and human health. This imperative is particularly true for our oceans. Today, despite the fact that they cover nearly 70% of the Earth's surface, our knowledge remains alarmingly limited. We estimate that less than 10% of the oceanic realm has been explored, and that over 85% of the species it shelters remain unknown. We have a clearer picture of the surface of distant planets, Mars, Venus, Mercury, than we do of the depths of our oceans. So we urgently need to close this knowledge gap. This is essential because it is science, your science, that must inform and guide our efforts to preserve marine biodiversity. You are the ones who can identify the species present in specific ecosystems and advise us on the best means to safeguard them. Protecting a coral reef in the Pacific is not the same as conserving shark populations in the Atlantic. It is you who can help us discover the invisible world of the deep seabed, of which we have mapped only 3%. Yet, these deep zones play a pivotal role in regulating our climate and harbor ecosystems that hold immense scientific potential. France has long supported and promoted this indispensable scientific work. Science is what shapes my decisions as Minister for Environment. It also inspires President Macron's actions. In the name of science, we have called for a ban on deep-sea mining, and we oppose reckless and unlawful exploitation that would take place in the absence of any international legal framework. In the name of science, we have chosen to invest in knowledge and research hundreds of millions of euros since the 1990s for marine science and technologies. In the name of science, we have undertaken missions of exploration and of inventorying the ecosystems that must be protected, and organized the national response through the French Ocean Observing System. And in the name of science, we are actively advocating for greater transparency and governance on the different international stage UNFCCC, IPCC, IPBES, COI. This does not, of course, exempt political leaders from responsibility. Politics is the art of choosing. But to make the right choices, our compass must be your work, not ideology, not political convenience, not financial interests, especially when we consider the long-term consequences of today's ecological decisions. Bringing you together here in Nice was, therefore, absolutely essential to enrich and illuminate the work of this UN Ocean Conference. But I must say this with gravity. Your involvement is all the more vital given the international climate in which we find ourselves. A moment where populism seeks to marginalize scientific voices, where in Utah a professor was forced to remove the word climate from his research title to secure funding, where NASA's former chief scientist, a distinguished IPCC co-chair, was dismissed amid budget cuts and a reactionary backlash against so-called wokeness, where academic freedom is being curtailed in established democracies, where climate skepticism is gaining traction among segments of the Western political elite, where some now equate scientific facts with mere opinion, as if all ideas stood on equal footing. In this context, I want to say this clearly: France stands firmly with science, true to its history and to the Enlightenment legacy. France chooses reason. This is why President Macron launched the initiative Choose Europe for Science, offering European refuge to researchers who can no longer work freely in their own countries. At a time where disinformation spreads faster than truth, when data are distorted and emotions manipulated, we choose facts and evidence. I have often reiterated this in European diplomatic forums when I advocate for the role of offshore wind power or nuclear power and for technological neutrality. It is not out of dogma. It is because science shows us that these are effective levers for decarbonizing our economies and reducing dependence on fossil fuels. The same principle must apply to the strategic decision we take here. During this UN Ocean Conference, science must remain our North Star. Science is also about doubt, contradiction, and questioning. The ocean remains a vast unknown. Many data are missing, and uncertainty persists. But this is all the more reason to invest, not to silence, politicize, or constrain scientific research. Allow me to conclude by expressing my deep pride in the excellence of French research institutions, many of which are leaders in Europe and in the world. I am particularly grateful to Ifremer and CNRS, whose expertise was instrumental in organizing this Congress and continues to inform public policy in maritime affairs. Ladies and gentlemen, dear scientists, thank you again for being here. Thank you again for speaking up. Thank you again for searching, finding, helping us to take the right decisions and making us aware when we are not taking the right decisions. I count on you to eliminate our discussions and decisions, and in return, you can count on me, you can count on France, you can count on Europe, and I'm sure that on many countries around the world that are not speaking up now, but are supporting you to ensure that you carry on playing this vital role you play today in shaping our futures. Thank you very much.
Thank you very much, Madame Pannier-Runacher, for those very wise words. Now I hand over to the moderators of the session, Daoji Li.
So the next keynote speaker is Minghan Dai. Minghan Dai is chair professor of marine environment science at Xiamen University, China, whose topic is about evolution and tipping dynamics of complex coastal systems. So please, Minghan Dai.
So thank you very, very much. And actually, I'm very moved by the message from the minister. Very encouraging about the science and inform the science to policy. So ladies and gentlemen, very good morning. I'm very incredible honor to speak here at the One Ocean Science Conference. And I'm also very much grateful to the organizing committee for the invitation. Today I'm trying to walk you through a couple of the hardcore sciences, just the minister said, and regarding the evolution, the tipping dynamics of the complex coastal system. This work is driven mainly by one of the urgent challenging, understanding how climate and human pressure interact to push our coastal ecosystem towards critical transition. I really want to showcase here that interdisciplinary science could be very much helpful to empower our capability towards prediction, which is an ultimate hallmark of solid science. So this is my outline and a little bit background about the coastal zone. And then I zoom into the tipping element and the tipping point in the global coastal system and also individual at the regional level. And then I try to link tipping dynamics and the policy and the governance. And finally, I will give some of the perspective in governance. So coastal zone is situated at the land-sea interface. The coastal zone represents a very typical complex system, if you want, comprising interconnected of physical, biological, and social subsystems. It is also one of the most heavily impacted region by anthropogenic activity. As such, the coastal zone functions as a regional Earth system under intensive human influence. Coastal zone are dynamic human ocean frontier, you all know that, powering global economic growth and supporting dense population. In fact, I just give you one number, 70% of the world's megacity lie along the coast, and the coastal area generates a huge share of GDP. I think I don't have to repeat many of those. And this slide just highlights the dual threats to the coast, very much intensive human activity, reshaping the coastline and the coastal ecosystem, and climate change powering on with high seas and extreme weather. So there is two main issues, I think, associated with the coastal system. The first one is the rapid expansion of the artificial shoreline, which has significant alter the physical dynamic of the land and the ocean interaction. As a result, we have lost 35% of global wetlands since 1970, a disappearance rate 3 times faster than that of global forest loss, if you want to zoom in the number. And China's artificial coastline expands even more rapidly than the global average, and has now created a so-called new Great Wall with functional collapse of the natural coastal buffers, if you want. The second main issue is the excessive fertilizer usage and the resulting eutrophication, which has led to a decline in ecological health of the coast zone. We now observe clear warning signals harmful algal blooms, green tides, degraded seagrass, you name it, a series of problems you see everywhere in the world. And if you look into the global footprint of the human activity and nitrogen loss, it's very much closely corresponds to the ecosystem response as elevate the chlorophyll level and extensive expansion hypoxia. That's the low oxygen level, if you want. One of the unfortunate things I observed is the migration of this coastal eutrophication from the Central Europe to North America and East Asia, now Southeast Asia and Africa. So this is really an unfortunate, never changed. That means the developing model has never changed. I just give you one example. It's happening now in Thailand, and showing here is the massive algal bloom you have seen elsewhere in the world and in the Gulf of Thailand in 2023, and associated with the massive fish kills in the September of this one. So that's a little bit of the background of the coastal zones. And now we just get into the tipping element and the tipping point and the coastal zone. And here I'm outlining some of these key concepts used to describe tipping dynamics. And this includes tipping element, that's subsystems that can abruptly transit to a new state, or tipping point, that's threshold driving system reorganization, cascading change from a tipping element, that's a tipping cascading and tipping process, there's a system behaving near tipping point, okay? And we are trying to diagnose the distribution of the tipping element in global coastal zone. So we screen metadata from 25,000 coastal related articles in the Web of Science, then use the expert-validated keywords spanning 10 tipping elements. I'll show you a little bit later. From this, over 4,000 global tipping element sites and events were identified and validated through a combination of AI-assisted method and expert review, and the geographic coordinate element classification was then extracted, enabling kernel density estimation to generate a spatial distribution map of the coastal tipping element. So that's the method we are using. And then we'll group into those tipping elements of the global coastal into 5 categories. That is the physical, biological, and socio-economical factors. I list all these tipping elements, for example, sediment morphology, sea level rise, coast currents as a factor of the physical system. Then I'm showing here, it's the coast hotspot of the tipping element concentrate, essentially along with the areas of high anthropogenic activity and the compound stress, primarily in East Asia, Europe, and the Eastern North America. So that's the very aligned with the human activity. And then I zoom in the 4 major coast regions in China. That's you see the color bar is actually the concentration density of the tipping elements. So sedimental geomorphology, sea levels rise, harmful algal blooms, and the key habitats all represent typical tipping element. However, these types actually spatial distribution show clear heterogeneity. And among them, the Yangtze River, actually near Shanghai, if you want, exhibit the highest frequency of the tipping element. So once we identify tipping element, the next step is to examine the tipping point, which are typically classified into 3 types: noise-induced, okay, and then bifurcation, and also rate-induced tipping point. I'm sorry about the mathematical equation. And here is one of the examples showing that more than 50% of the beach and the wetland habitat could vanish with 25 centimeters of sea level rise. At 1.5 meters, it's a system-wide collapse. So that's one of the examples how the tipping point function. And seagrass ecosystem illustrate how systems move from healthy to degraded states. Water quality and the biodiversity shift can push them into an irreversible decline. That's an example. So I'll give you one of the real examples. The East China Sea dominant species in algal bloom have shifted from diatom to dinoflagellate, showing the system may have already been in a new state since 2004 or 2005. So that's the real example of the East China Sea. So tipping point inherit, we all know that's very difficult to predict. So we're trying to find early warning signal. These are also often granted in the theory of the critical slowing down, which means that as a system approaches a tipping point, its recovery rate following perturbation slows, resilience weakens, and the time required to return the equilibrium states increase. So classic early warning indicators include rising autocorrelation and the variance, as this system level of property tend to increase prior to a critical transition. And there is also some of the indication we can use for such as the Curtison's detrend function analysis, for example. So I'm just trying to zoom in a little bit. We use the autocorrelation coefficient as the early warning signal. Again, this is reflects how strongly a system current state depends on its recent past. So it's the memory actually effects measurable can serve as an early warning indicator. So based on this analysis, I'm showing that significant tipping process actually related to tidal flat change have already emerged across China's 4 major sites. In the Yangtze River, upstream hydraulic engineering has actually trapped the sediments, resulting in marked tidal flat retreat and crossing a tipping point. And the other 3 areas in the Bohai and the Great Bay area of the Hong Kong area is ongoing towards the tipping point. So that's what's the theoretical analysis of the tipping element and the tipping points. Then I'm zooming into the tipping dynamics related to the tipping governance. Actually, tipping in the tipping process have their roots in physics and climate science, but now are being extended to the social system and the governance framework. And I think understand the tipping dynamic can empower coastal governance through at least helping prioritize action, add adaptively, plan adaptively, and adopt system thinking to manage complexity. So this slide illustrates how timely and well-targeted policy intervention can help delay or even prevent the crossing of the critical tipping point. Without timely policy intervention, systems are vulnerable to negative tipping. A striking example I'm giving here is the collapse of the large yellow croaker, once a very prized state fish in China. In the 1970s, the species experienced dramatic decline. 2 major harvest events actually accelerated the crops. The drum beating harvest in 1967 and overwintering ground harvest in 1974, which devastated marine population. This case clearly underscored how missed the regulatory window and the uncontrolled exploitation can rapidly push a system beyond the recovery. I think it's a very clear example here. And I think the Great Barrier Reef trigger system is a pioneering, on the other hand, the model of proactively marine environmental governance. It was designed It was designed to protect the grid barrier from continued degradation due to poor water quality, climate stress, and the land-based pollution. The core mechanism here is the trigger system is built on predefined environmental tipping. It increased scientific monitoring with predefined policy threshold, which then triggers specific management response. In the following section, I'm trying to walk you through several case studies that illustrate how tipping element, tipping points, and the policy response interact in the real-world coastal system. The first example is the Baltic Sea, which is well known, I think, for eutrophication and hypoxia. Despite decades of nutrient management effort aimed at curbing eutrophication, the area continues to experience widespread hypoxia. So here, multiple potential tipping elements, including sea level rise, sediment morphology, HAB, hypoxia, coastal currents, fishery, economy, and the policy coexist. So based on the rising autocorrelation I just explained, our analysts review a cascading effect, actually, where dominant variables such as critical stress in sequence, and from the physical point, physical and biogeochemical and biological. And this multiple layer trajectory suggests strongly coupled feedback system that underscores the value of integrated early warning system to anticipate change and to understand the order and interaction of tipping element within complex coast system. So this case highlights how delayed intervention and the long ecological feedback loops can undermine even well-intended policy. The second case is the Chesapeake Bay. We know this is the largest estuary in the US and has long been suffered from seasonal persistent eutrophication and hypoxia after 1960s, mainly driven by the intense use of fertilizer usage. So similarly to the Baltic Sea, multiple potential tipping elements existing in this area. The seagrass as an indicator showcased the system change. Back in 1980s, a sharp drop in seagrass was observed, and then restoration effort began while remained, however, unsatisfied. So correlation analysts revealed that seagrass ecosystem might have reached the tipping point around the year of 2002. So this is another example. So the implication here is really despite the sustained policy effort, actually, recovery has been slow and uneven. So I would argue that what's needed now is a tipping framework for recovery, one that identifies and amplifies positive feedbacks, leverage early signs of rebound, and strategically push the system towards a more resilient ecosystem state. So my third case is the Bohai Sea, actually located in northern China, where sea level rise. Again, all these tipping elements coexist as a potential tipping element. And I'm using this case actually really the fascinating alignment between ecological dynamic and policy intervention. And here we use another indicator, the entropy of the system. This is the entropic microstate, a measure of the ecological order, shift over time in close correspondence with the extent of red tide outbreak. More importantly, the entropy lows or periods of relative ecological order align close with the key moments of the national policy action targeting the Bohai region. So this suggests that the government regulation has played a role in restructuring the system's internal state, potentially averting further deterioration. The final example between tipping element and tipping point, actually I have already shown the Changjiang River Delta with the tidal threat actually crossed the tipping point because the infrastructure-driven disruption that can accelerate the regime shift in coastal morphology. So that was the example and the case study worldwide. We just try to link the tipping element, tipping point, and the governance. Finally, I'm trying to spell out 3 perspectives. And early warning with cascading awareness, and the polycentric decision support, and the finance-linked resilience planning. I'm finish up. The first priority is to address cascading risk effect and the critical threshold process. And resolving this, I think, would significantly enhance our capability for timely and effective intervention. The second case perspective is the emphasize upgrading decision supporting system. I think the current platform often remain linear, static with inherent response delay. So digital twin technology, for example, enables dynamic, nonlinear, real-time environment. This evolution will transform passive data dashboards into dynamic intelligence system capable of adaptive policy intervention. I think it's extremely important. Finally, we propose developing an integrated model that captures feedback between socioeconomic activity and the coastal environment that enables early detection of hazards and the sustainability gaps. I think I skipped get to the concluding remarks. So again, coastal at the forefront of global change, where human activity and climate pressure converge, reshaping coastline, disrupting land-sea interaction, and destabilizing the ecosystem. Many system approaches of health have already crossed tipping point. So tipping is real. And the science of tipping dynamics offers powerful tools, and from early warning indicator to coupled Earth system model to detect a critical threshold informed adaptive intervention. I think by integrating natural social system thinking supported by digital twin, artificial intelligence, and the policy innovation, we can shift from reactive response to proactive governance. Ensuring coast sustainability requires urgent, science-informed, and co-designed action. Only through global collaboration we can safeguard the resilience of coastal oceans. That's also, I think, is the goal of this symposium and Congress. With that, I thank you all very much.
Thank you, Min Han Dai. Now there are 5 minutes to ask a question. 5 minutes and answer. Yeah, who's first? Yes. Question?
It's a good indicator.
Yeah. Oh, yeah.
Yes, thank you very much, Min Han. How do you connect this narrative that you have provided us regarding tipping points with the previous work you have done concerning RCCO2 fluxes in the coastal zone? Can you elaborate a little bit on that?
I'm not sure I got the question yet.
Well, what is the impact of tipping an ecosystem for a coastal ecosystem for RCCO2? Yeah.
For air-to-air interaction?
Yes.
That's a good question. The impact of the tipping point at the system level, as also at the elemental level, and so it's a good. I haven't thought about that. How, for example, the coastal system would respond to the collapse of the ecosystem across the tipping point in terms of LCCO2 and the carbon sink and the carbon, but essentially, we are stepping into a fluctuating area from the land, and so projecting CO2 signal into the ocean, and also this extreme weather. I think there's a lot of uncertainty over there.
Thank you. Then any other question? Okay.
Very interesting. Thank you so much. So you've actually highlighted like 2 cases where, despite regulations, it was still not restored enough. So this is giving a bit of negative message for policymakers who might be here. So why is that? Why do you think is that? I mean, even after regulations, for example, in the Baltic, let's say Baltic Sea, we still have this like hypoxia and other things. And do you think the approach that you are using, I mean, how certain it is? So what's the degree of certainty and how reliable, how really it could be globalized or applied in many areas like you've shown? So, yeah.
Yeah, there's all very good questions. The tipping, that's the lesson experience we really want to gain, and try to link the tipping dynamics and the policy intervention. I think the Baltic Sea is a typical and a very good example. When the system crosses the tipping point, it's very hard to make the policy effective. And also, the world, the ocean is changing. So there's a new emerging climate effect, for example. So really, we need empower the scientific early warning system, and then the regional system model as well, to have this multiple dimension vision to predict the system's change. Then we can enforce the adaptive change policy. And a good question. This work has been just started, I think. We used, at the beginning, I was trying to emphasize the interdisciplinary science between ocean science and the mathematics and physics, and can give you the power to actually the sign to empower the capability to prediction. This work had just started, and in the beginning we have been working with the different disciplines. I think that we have the hope to solve this the problem using autocorrelation or ergon microstates. It's a typical used by physics and to quantify, measure the early warning signal, and also this critical slowing down process. That's but it's still need more work, and I think cross-sectoral collaboration is essential to move this forward. But at least it's hopeful.
Thank you, Mihanda.
Thank you very much.
So, last, but certainly not least, our final keynote speaker is Sheena Talma. Sheena is a marine scientist from the Seychelles. She's currently pursuing her PhD in deep sea biology at the University of Oxford in the UK. And she's not only an impressive scientist, but a wonderful human being. Sheena's talk is entitled, Understanding Prioritized Deep Sea Research in the Indian Ocean.
Thank you so much for having me as one of your keynote speakers. It's a real pleasure to be here, and perfect. Thanks. Right, so today I'll be talking to you guys a little bit about the work we've been doing in the Indian Ocean, specifically in the Seychelles. Like we've heard today from our speakers, it's important to know where we've come from to understand where we're going. So the past, present, and future of our science depends on that. And I wanted to start us off by thinking through a phrase. Now, this specific phrase says, a team of explorers, researchers, set sail on a deep sea mission to uncover unseen parts of our ocean, helping protect 30% of our ocean for the future. So my question to you today is, who do you think of when you think of the explorer or the researcher? Who is the first person that comes to mind? Who is that demographic that you think of when you think of those two words. The other question is, where are we going on this journey? Is it to the Indian Ocean? Is it to the Atlantic? Today I'd like to share how this little kid on your screen started her journey to the deep ocean. So my journey to the deep sea started actually with frogs. I like to explain that my journey from to the deep sea is a lot like the course that a river takes from the mountain tops. And this was probably the first interest of wild animals for me. Okay, I didn't have the exposure to things like, to lots of documentaries. So looking at the animals in my backyard was where that love for nature started. And like the river leaves the mountains and makes its way down into the estuaries, my journey did the same and took me to the seashore, where I became obsessed with turtles. I don't know if you can see it, but there's a little bit of an obsession with cold-blooded animals so far. But one thing that I didn't tell you is that whilst I dabbled in the ocean and I had a very complicated relationship. And that's because I had a really bad experience where I nearly drowned, and that meant that going back into the sea was very difficult. So I did one of the most difficult things I think I have ever done in my life, was to get back in the ocean to dive. And for many who have been able to experience breathing underwater, I think you can all agree that it is a magical experience. But this is where I realized how much of our underwater world we still didn't know about. So I studied, thank you. So I went away and studied fishes, again, cold-blooded species, for about 7 years in South Africa. But this was really just the beginning. Because if we think about the Seychelles, 95% of our waters is actually deep ocean. Now, you can't take that tank down there to below 200 meters to explore it. So the first time that I laid my eyes on the deep ocean was in 2019. I had come back from from South Africa, and I was working with the government of the Seychelles, and Necton had showed interest to work with the government of Seychelles to highlight some of these deep sea areas. Now, being able and being privileged to remove the tank and get into a little submersible to explore these parts of our planet that we often don't get to see was life-changing. And this is where I decided the deep sea is where my journey will end, and I will stay here and study this habitat. But this was also the beginning of deep sea research in the Seychelles, that collaborative experience, at least for the Seychelles. So let's take a look at what we've done in the past, what we're doing right now, and what we'll be doing in the future. Like I said, in 2019, there was this collaborative relationship between the Seychelles government and Necton to to explore our deep waters down to about 300 meters. And this came at an opportune time. The reason for that is that we were just finalizing our marine spatial planning. So we protected 30% of our ocean in 2020. And it was highlighted how much we actually didn't know about these deeper environments. So the first areas that were prioritized were these areas of high biodiversity. So all of these little squares show you different island groups that were prioritized based on the fact that as part of the modeling and part of the marine spatial planning, they were highlighted as important. In 2022, another expedition came through. This was a Monaco expedition, and the Seychelles team advocated to run the ROV surveys, because we had already done it with the Necton expedition. And as you can see, the team of women on board led that work package. In 2024, we shifted into PIing our first expedition. I was proud to be able to do that with a team of amazing early career researchers. The idea here was to be able to pass on our skills to a co-lead in every work package, so that next time a deep sea expedition comes our way and knocks on our door, there isn't just one person that has to go on the ship and be able to collect the data that we needed. So the areas we went to, we decided collaboratively with the government and the different parties, was to go back to similar areas that we had gone to in the past. So with Necton, etc. And some of the things that we really wanted to gain was as much mapping as possible. Why? If we map, at least we know what it sort of looks like at the bottom. And if we can invest in our own instruments, we can then deploy it ourselves. Some of the amazing things that we saw on one of our exploratory dives at 4,500 meters in the Amirance Trench. That was at 4,000, and this is at 1,000 meters, the Teningia dene, or an octopus squid. This was the first sighting of live sighting of a Teningia dene in the Seychelles waters. So, what have we learned from our past? We've been able to come up with methodologies that we have replicated throughout all of these expeditions that have come into our waters. We've been able to expand our depth ranges from the beginning, maximum of 300 meters, then to 500, with Ocean X consistently down to 1,500 meters, as well as our exploratory dive to more than 4,000 meters. And of course, there was a leadership transition. We started off being participants, then leading work package groups, and then to leading the actual expedition with the expertise of the team on board. What are we looking at the moment? What does our present look like in the Seychelles? So, when you think about these amazing platforms, it's like being upgraded to first class, right? And then suddenly, you don't even have a plane to get on, right? Bit of a problem.
What do we do now?
And yes, and we often think like this.
What do we do now?
What are we gonna do, like these damsels in distress? But we took matter, and I mean, it's understandable. Let's go there first. Because access to the deep sea vehicles there are big, what's the word? Discrepancies, right? Like the global north, so what we're seeing here is the dark colors show you where surveyed individuals said that they had access to deep sea vehicles. The lighter colors are showing you where people said that they didn't have access to deep sea vehicles. And as we can see, this is concentrated in developed countries. Whereas developing countries, you know, there's some problems there. And this is highlighted further by the second paper, also by the same group, Ocean Discovery League, showing how much we've actually visualized in our deep ocean. All the colors kind of show you, it's a heat map, so it shows you where there's been actual deployments of gear around the globe. So out of this 66% of our deep ocean, only 0.001%, based on this paper, has been visualized. That is about the size of Belgium, tiny. And most of that work, has been done by 5 main countries, and that is the USA, New Zealand, Japan, France, and Germany. And the majority of that has been done around countries like New Zealand, Japan, and the US. So of course, we need to come up with solutions that will work for us within our system. So we worked with, again, the Ocean Discovery League to test a prototype. So this is a type of camera, because we decided that visualizing the deep sea is the first thing that we would want to do. And this camera, the great thing about it is that you're not afraid to lose it, because it's quite cheap, the parts can be reprinted, etc. So we raised money online through the Experiment platform. If any scientist in the room needs some extra money for their research, this is a great platform to do it through. And we also got a small grant from the National Geographic Society to test out this specific system. Now, we tested this in different parts of the Indian Ocean. Generally, I was begging and bartering to get on to as many ships as possible. It's very hard to get on a ship. And one thing that we learned very quickly is that you won't deploy a piece of equipment unless you can retrieve it. So with this specific system, we didn't have lights, and we didn't have a way to retrieve it back to the surface. So all of these deployments, they were attached to another bit of equipment, which kind of takes away from the whole point of us doing this work. We want to be able to do it unassisted from small vessels. So instead, we repurposed it, and we've been teaching kids about the importance of deployments and how to collect data with the little infrastructure that you have. We then tried a different system. This is also a great system. It can go down to 6,000 meters from the National Geographic Society. Our biggest issue here was that we couldn't keep the system. We could only use it for a short period of time and then give it back. Again, our issue is repeated, that we need the system to stay in our waters. So what are we doing now? So I'm proud to say that as of the 3rd of June, it was announced that we have been able to get a grant through Rolex and National Geographic as part of the Perpetual Planet Ocean Expeditions, where we'll be leading our own research in the Seychelles as of next year, where we are building landers. So these are deep sea ROVs with our South African partners. And the idea here is to be able to have the system that stays in the Seychelles with us, train more people to be able to visualize our deep ocean, whilst also collecting data that can be used within our fisheries. And this is what we're hoping and expecting that we will be seeing. This is the equipment that was same equipment tested in the Maldives during a Necton Maldives expedition in 2022. Hopefully we'll see as many 6 gills as we saw in the Maldives in the Seychelles as well. But the other reason we've chosen to go with a visualization system is because we need the people to get on board. If you can't see yourself as a deep sea scientist because you don't have that role model, or you don't have the equipment, why would you even venture into it? So we, every time we go out, we generally have town halls where we also share the information that we're getting from our own deep sea backyard with our community. So, what are the take-home messages? First and foremost, what we've learned through working with different partners is that co-production is key. Co-production, I know, has been overused, but to be able to build a relationship and a partnership that is long-lasting, you need to invest the time to allow partners to trust you, especially when we're talking about global north, global south relationships. Leadership. We need to be able to shift the leadership of who is leading the research, especially when it's being performed in our own backyards. For a long time, we've had situations where research comes out from the Seychelles, for example, and the people don't even know about it, or there isn't any collaboration from people on the ground. If you want to read more about that kind of inequitable research, please have a look at Dr. Asher DeVos's papers on parachute science. The other key thing around leadership is the fact that if you become an expert in my waters, then I will never be able to fill that gap, especially if it's not done in an equitable way. The other thing that Dr. Asher DeVos says is that capacity is equally distributed, but the opportunities are not. And that is the truth, right? We all have the skills, we all have the ability to learn. How do we ensure that we are equipping our partners with the skills or the funding to allow them to take the lead? Time. We all work on different time scales. Often when we work with partners, we make it very clear that we do work on different time scales. And whilst they might need a paper in a year, we might only have the availability to do it in 2 years. Because especially when you're from a small island developing state, you wear many hats, and that occupies a lot of your time. So unless it's paid for, you kind of have to make sure that you spread yourself across different portfolios. And metrics. We all have different metrics that we go by. Whether you say your success is 10 papers per year or 5 papers per year, mine might be ensuring that my community trusts me as a scientist. So I'd like to leave us with going back to this. And I want to get this right. So imagine that the team of explorers or researchers set sail on a deep-sea mission to uncover unseen parts of our ocean. But this time, imagine that this team is from Mauritius, the Maldives, Kenya, Djibouti, South Africa, Madagascar, from the global south. And they are setting off to explore unseen parts of the ocean in coasts around the global north. That idea feels a bit radical. But flip the map, like my colleague said, and ask ourselves, how would we want to be engaged? And on that note, I would like to say thank you to all my partners who make this work possible, both from the global north and from the global south. And I will leave you with this small video whilst you think about your question.
What makes us unique in our universe is that we have water. And most of our water is seawater. It's the foundation of everything else that exists here.
Which is why National Geographic and Rolex are on an urgent quest, launching innovative expeditions from seashore to seafloor and from pole to pole, partnering with coastal communities to develop solutions that will help protect and rebalance our planet's largest and most important ecosystem. And to remind us that our one ocean doesn't divide us. It unites us.
So, after that phenomenal talk, questions? Bashina.
My colleague said that it's a good sign if there's no questions, so I'll take that as a good sign. But there is one.
Oh, thank you, Kira. Kira from New Zealand. So thank you very much for this amazing talk. So coming from New Zealand and from France, as you can hear from my accent, but mostly from New Zealand, I cannot agree more that the south at the top is the way to go. And there is no wrong or right. It's not provocative. It's the way it is. Anyway, to my questions, I wonder whether in your last slide you had co-production, leadership, capacity, time, and metrics as sort of a key points to take in back from your talk. I wonder whether the notion of what's the word I'm looking for? Values, that's values of people. People have different values, and that's something that always impacts on all of things. So you've got the values from the Western world, you've got the value from the small Pacific Island nations and the Indian Ocean nations, how the value will distort some of those metrics. Can you comment on that? Thank you.
That is a great question, and thank you for it. I believe, yes, we do have different value systems, right? But if you decide to have a partnership, you would invest the right amount of time to understand those different value systems with the people that you're working with. What I've sometimes experienced is that even if we do have different value systems, if we align with regards to what we want to do, and you invest the time to be able to understand each other as partners, then the project or the program will generally be successful.
Other questions for Sheena? In front? Stripy shirt.
Hello, I just had a question about landlocked nations, and if a lot of people don't have access to the sea, so how can, as an ocean scientist, how can we help preach to help reach nations who don't have the privilege to do deep ocean research? And
that is a brilliant question. Thank you so much for asking it. And I do think that that is indeed an issue that isn't addressed often. As part of the biodiversity beyond national jurisdiction, landlocked countries are part of the group that are meant to benefit from the different packages of the BBNJ. So that is one way in which you can advocate for it. I think that one thing that I really want to emphasize is that we believe in collaboration. And that doesn't matter where you're from, because at the end of the day, our ocean is what is keeping us alive, right? Without the ocean, there is really no us. And that doesn't matter whether you're at the coast or in the middle, right? But what we do see is that coastal countries generally bear the burden of ensuring that our ocean is healthy. And those coastal countries are generally from the global south. Okay, so we have learned to be stewards because that is all we have and that's all we depend on. Thank you so much.
Thank you, Sheena. Great talk. A question about where your message lands, maybe to you and perhaps other members of the panel. Where do we take this message? Where is it written down that we will commit to leaving the equipment there and make those sorts of commitments when we're doing this sort of work? I'd be keen to hear your thoughts on that. Maybe it's already written down.
That's a great question as well. I mean, there are publications that talk about this already. When we are, however, speaking about ensuring that equipment stays in country or that there is access, I think something that we have to remember is that each region, each island, each nation is very different. And each capability, therefore, is very different in what they can then use, what kind of equipment they can use, etc. So often we actually have to tailor how we approach leaving equipment behind as much as possible. This is also part of the BBNJ agreement, and it is essential that even when the agreement comes online, that the countries that are doing the work, especially in the Global South, are the ones that say what kind of equipment they can deal with. I think there is the tendency of just leaving equipment behind, which then actually becomes a burden. And that's where that collaboration and co-creation is really important.
We'll do one more, Anna, and then close.
Hi, thank you, very great talk. And I have a comment and a suggestion. Well, I'm not from the Global South, I'm from Global North, but I'm not from one of the 5 countries that are going to the deep sea. So there is a lot also parachute science and lifts on board other vessels, the Rolls-Royce vessels, as you said. But I also live in a region that we also have 95% of our seafloor, it's deep sea. I live in the Azores in Portugal. And as you did, we had some colleagues that start developing these low-cost instruments. And of course, there are a lot of things that we cannot do with the low costs, but other ones that we can start doing and sharing knowledge in between these Global South and Global North, because I think that I saw your cameras. We have some similar ones, but they travel. I saw that you have a lander. We have a similar lander, but with different configurations. So maybe we could start kind of a low-cost technological group under a framework like DOSI, for instance, or other platforms, that we could share this and be able to learn from each other how we can use the low cost in fishing vessels, in military vessels, in cargo vessels, etc. Thank you.
Thank you, and great comment. And actually, I'm in touch with your colleagues as well. So actually, there is a group that exists under DUS called the Accelerator Working Group. And we came together in 2 years ago to kind of discuss what does low-tech look like going forward, and whether that is the appropriate name for it as well, right? So the group does exist. I can definitely share that with you as well. But yes, there is a huge movement to democratize our deep ocean, and that's the way we should all be going. Thank you so much for that comment.
One more time, thanks to Sheena and all of our speakers. And just a reminder that the entire program for the rest of the day is going to run 15 minutes late.
And we will take 2 more minutes from the coffee break. Sorry about that. I would like to invite Adina Payton. She wants to do a 1-minute intervention.
Thank you, Jean-Pierre and Francois, for letting me enter the program impromptu. I'm just representing myself as a single scientist from the US that is here, but I know that all of my colleagues in the US and the few that have made it here share the same sentiment that I have. I just wanted to take the time to thank the organizing committee, France, Spain, the EU, all the rest of the nations that are supporting our fight for freedom, integrity, and diversity of the scientific endeavor, and for providing opportunity for scientists to come to your countries, continue their work. I do want to pledge for one additional thing. We also need to maintain the science in the US. And I realize that we cannot depend on taxpayers' money from France to support science in the US. We have infrastructure, we have ongoing monitoring, research programs, and most of all, we have hundreds of PhD and master's students that have lost their support for doing their scientific work. So maybe through some philanthropic or some other ways we can put our heads together and figure out how to continue doing science in the US as well. Thank you.
Thank you, Dina. I would just like to say that every time there was a question about the situation in the US, I always started by paying a tribute to what you have been doing in North America, the extraordinary work that has been done in oceanography. I think this is the first thing that we have to acknowledge, and I hope definitely that this will continue for many years to come. With that, I would like to invite two ladies, if I'm all right. I don't know where they are and whether they are here, but we would like to have May Butel and Laurie Lawrencery on stage. Are they somewhere? Here is May. May, by the way, do you know where Laurie is? No, you don't know.
I know where she is, but she's busy with everything for this afternoon, so.
So what we have asked, please come in the middle. We have asked May and Laurie, who cannot make it because she's doing other things for the benefit of all of us, because we wanted, Jean-Pierre and myself, to warmly thank you, both of you, for what you have done for the organization of this One Ocean Science Congress. I know there are other people who played a role, but definitely May here, near to Jean-Pierre in Villefranche-sur-Mer, Laurie in Brest, a bit farther, but you played, both of you, a real key role that is a bit hidden, but we wanted to put some light on it. So thank you so much. And normally there should have been a small gift, but it has been lost because May was not in charge of it. If she had been, probably we would have had on time. So, but you will get something in Laurie too. So thank you again.
And I just want to say thank you both for your trust, and thank you everyone for coming. It was really great to have all the countries represented and all the talks. From what I hear, I haven't been able to attend many sessions, but from what I hear, it was really great discussions. And also thank you to the International Scientific Committee and everyone for their trust. Thank you.
Okay, now it's time for coffee break. A short one, I'm sorry. And the sessions will resume at 10:45. And the program will end at 12:15, excuse me, 12:15, and it will be time to go.